Okay, today we're going to take a look at the remaining two ways that triangles are similar. And the first one is side-side-side similarity. And if the lengths of the corresponding sides of two triangles are proportional, then its triangles are similar. When we take a look at the side-side-side similarity, it is the same as congruence except for the sides being proportional. And then if the SAS similarity is very similar, if an angle of one triangle is congruent to an angle of another, then the lengths of the sides, including those angles, are proportional, then the triangles are similar. The SAS similarity is going to work the same way as the congruence piece did, in the fact that you have an angle with the sides on both pieces around them that are going to be proportional instead of congruent. Okay, so those are going to be some of the things that we're going to be looking at here as we go through our lesson. Okay, the first thing that we want to look at is whether triangle DEF or triangle GHJ is similar to triangle ABC. And we're going to look at this through the different colors in our picture, and it might not be quite as easy for you guys to see with the pictures, okay, with the color. Okay, I've tried to get it up as close as we can, where I can still write. Okay, when I take a look at my angle or my sides, the one thing I want to recognize is that over here I've got an angle or a side that's 8 units long. Okay? And with that side that's 8 units long, I'm going to compare that to the triangle clear over on the right hand side. Okay, well that's 8 units as well. Both of those are red. Okay, now when we take a look at those two sides, the next piece that we want to look at then is the blue piece. And on our blue piece, in both those first triangle and the last triangle, they're both 16. So far our sides are proportional in the fact that they're both congruent. But our remaining side is the green side. And with the green side, what we're going to see is that this side here is 12, this side over here is 10. In order for all three sides to be proportional, the sides in green would both have to be either 10 or both would have to be 12. Since we do not have that, we know that our sides are not proportional. So now we're going to take a look at the next triangle. Okay. Now I'm going to compare my first triangle with this one here in order to find whether DEF is similar to ABC. So I'm going to take that side, I'm going to take 9 over 12. Okay, and that's going to give me 0.75. Okay, so I know that I've got one of the sides that has a ratio basically of 3/4. Now we're going to check the next one. We're going to go with the blue. So I'm going to go with 12 and 16. And a check is 12 over 16 in the same ratio as my green. It was 0.75, and it is. And then our last one is the red one. Okay, and with our red side is 6 and 8 in the same ratio. So I check, is 6 over 8 the same ratio? And that's 0.75. So I know that all three sides are going to be the same. Okay? So in the end, I know that triangle DEF is the one that's similar to triangle ABC. What we're going to spend a lot of our time with today is identifying how the triangles are similar. Okay, for example, if we take a look here in the triangles, there's two sets. You've got these two right here where we're going to compare side lengths. Okay, and you want to go with the short side first, then your long side, and compare that so that the part that's in the middle is exactly in the middle. Okay, 6/9 we know to be 2/3. That's 0.6 repeating. 8/12, 0.6 repeating. And 8.8 over 13.2 is also 0.6 repeating. So all of our sides have that same ratio of 2/3. Okay, so these two triangles are similar by side-side-side similarity. Our two on the right-hand side are actually stacked. And remember that when you've got vertical angles at the center, that those angles are automatically congruent. Okay, and as a result of that, those two triangles then are similar by AA similarity. Okay, angle, angle. Our next example deals with a small triangle that's stacked on top of a big triangle. Okay, so the small triangle's there in red. You've got a shared angle here that's going to match, plus you've got your two right angles here, so those two triangles are similar by angle-angle similarity. Our remaining set of triangles that we have on this slide can be done a couple different ways. One of them is to go ahead and realize that these two angles here and here add up to 100. Okay, which means my missing angle up top is 80 degrees. Now, that means that I've got an 80 and a 30 here, an 80 and a 30 here, which means that those two triangles are similar. Okay, by AA. Similarly, I could also take these two pieces here of 8 and 12 and the remaining sides of 10 and 15 and compare those ratios. Okay, so I've got the ratios there that are going to tie as well. That's going to give me 0.6 repeating and 0.6 repeating. This angle here is going to be 70 degrees. So that would be an included angle, and that would be an example of side angle side similarity, where you have the two sides that are proportional with the angle in the middle being congruent. Our remaining two from this section, okay, I've got the two small triangles stacked over top of a big triangle. Now, I've got these arrows here which tell me that those lines are parallel, which means that these two angles here are congruent, these two angles are here are congruent. We only need two. So we have AA similarity for that one, even though this angle up here at the top is going to be similar because it's in both triangles. And then we will finish over on this triangle. I'm going to take 21, I'm going to divide it by 4.2. I'm going to take 17, divided by 3.4. I finish with 15 divided by 3. All of those are going to give me side length ratios of 5 to 1. So those two triangles are congruent by SSS. When you have your vocab quiz, something that you're going to need to know are the three ways that triangles are similar. Okay, number 1, AA. 2, SAS. 3, SSS. Notice that these are the same ways that triangles were congruent back when we did our triangle congruence unit. The difference again is the fact that with AA, you don't have to deal with any sides for ASA or AAS. And then with the SAS and SSS, the sides are proportional instead of being congruent. Okay, a couple more examples. When you have an isosceles triangle, one of the beautiful things is those two sides already that I circled are in the same proportion. It's 18 over 27 and 18 over 27. You know those two are the same. The other side that you have to check is the base side, the one that's not congruent. So you're going to take 18 over 27 and 10 over 15. You get 0.6 repeating. And then lastly, on number 2, we have the angles here at K and M that are congruent. So what we're going to check is our two side lengths. I've got a 12 and a 16 here and here, and then 16 and 20. Okay, so now what we've got to do is check our ratios for those two. Make sure those ratios are the same. So it's going to be 0.75 and 0.8. So these two are not similar. Okay, here's another example. This time we've got again a small triangle here in red that is going to be surrounded by a big triangle. Okay, it's overlapping. When I look at my small triangle on top, my side is 24. My entire length then is 30 because I've got to include both those pieces. Similarly, 28 is going to deal with 35. Okay. When we work through those two ratios, both of those ratios are going to give us 0.8. Now, I have two sides that are proportional. This angle here at R overlaps in both triangles. So these two triangles are similar by SAS similarity. Okay, our triangle is similar, so we're going to state our similarity. Again, we've got isosceles triangles, so the 45s and 30s, those two sides are already proportional. What we need to check then is whether the 50 and 75 is proportional as well. Okay, both of those are 2/3, so we're going to get 0.6 repeating when we try those out. And number 1 is similar by side similarity. We look at number 2. Angle B and Y are congruent. So I've got my A. I need to check my two S's. I'm going to compare 9 and 18. And that's this 9 and this 18. And I'm going to check the 18 here and the 36 and compare those ratios. Both of those ratios come out to be 0.5. So because those two sides are in the same ratio, and I've got the angle in the middle, the triangles are similar by SAS similarity. Questions on that? All right, so I'm going to use my diagram, and which of the three triangles are similar, write a similarity statement. All right, so I'm going to take a look at my smallest sides. I'm going to kind of guess as to which ones I want to try first. And if I take a look at those sides, I want to compare the 20 and the 30 first, only because they end in 0. Okay, so I'm going to try that one first. So what I'm going to do is compare triangle LMN and triangle XYZ. So the rest question is 20 over 30 in the same ratio as 24 and 36? These two are my middle pieces, so we're going to compare those. And then finally, I'm going to compare the 26 and the 39, because those are the two biggest ones. Both of those are divisible by 10, so this is 2/3. 24 divided by 36 is 2/3, and 26 divided by 39 is also 2/3. All of those ratios are the same. So triangle LMN is going to be similar to triangle, and then we got to start looking at this a little bit. Okay, now L. I'm going to switch to a yellow color. You'll notice that L is between the smallest side and the biggest side. So when I look at this triangle over here, here's my smallest side and my biggest side. Notice that Y is inside of that. So that means that Y is going to be congruent to L. M is between the 20 and the 24, so it's between the smallest and the biggest. That's going to match with Z. And then we got X to finish up. So triangle LMN is similar to triangle YZX. I'm not even going to mess with RST because I know that that's not going to be similar. Okay, because if I got one set, I'm good to go. But RST comes into question number 2. The shortest side of triangle is similar to RST, is 12 inches long. Find the other lengths. So if it's 12 inches for this comparison between this, my smallest side on this triangle is 24. So 12 over 24 is going to give me 1/2. So my triangle at the bottom is going to be 1/2. On number 2, it's going to be 1/2 the size of the triangle with RST. So I know that 1/2 of my size is going to equal 30. So 1 times 30 is 30. It's going to equal 2x. I'm cutting it in half. So x is 15. So my side length was 12 and 15. And the remaining side length has to correspond with 33. So 1/2. My triangle I know is smaller, so that's why x goes on top. Remember, put big on the bottom. 33 equals 2x. So x comes out to be 16.5. So my remaining sides of my triangle then are 12, 15, and 16.5. Okay, a couple applications yet here to kind of finish this lesson off. I want to find the values of x that makes triangle ABC be similar to triangle DEF. Okay, now I have an x in both parts, but I can see down here on this piece where I've got 3 times the quantity of x plus 1, I have to use the distributive property. I'd rather avoid that. So this x minus 1 is going to be what I'm going to use. The 4 and the 12 are in corresponding positions because AB is similar to DE. So 4 over 12, my x minus 1 is on the smaller triangle, so it's going to go on top. and BC matches with EF. Well, EF is 18. So we're going to cross multiply. 4 times 18 is 72. That equals 12x minus 12. We add our 12 back. So 84 is going to equal 12x. And my value for x then becomes 7. Okay, find a distance across our lake shown if CD is 120 feet, DX is 90. AX is 180, and I'm trying to find this distance here from A to B. So that's going to be my giant X. Now, if I compare my pieces, the 90 here is on a slant with 180. So I'm going to go with 90 over 180. Okay, and to help myself out, I'm going to simplify that down. That's going to simplify to 9/18, which is 1/2. And then that's going to include the 120 then over top of X. So 1x is going to equal 240. And we're done. So it's 240 feet to go across the lake from points A to B. Okay. You're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it's similar to left end using the angle measures and length shown? So what I'm looking at is this triangle here, is that similar in size to there? Well, we know that our angles at A and F are the same. So what we need to compare is 6 over 9 in the same ratio as 10 and 15. Okay, 6 over 9 simplifies to 2/3. 10 over 15 simplifies to 2/3. So the answer to the question is yes by SAS. So our triangles are similar by side angle side similarity. Okay, our last example is a two-part question. And on the first part, we're going to convert everything into feet. A flagpole, whose height we don't know, casts a shadow that is 50 feet long. So my shadow is going to go on top. I have a woman standing nearby who's 5 feet 4 inches tall. Okay, so if I have 5 feet, I'm going to multiply it by 12. That's going to give me 60 inches plus the 4. So my woman is 64 inches tall. I want to be in feet though. So what I'm going to do then is I'm going to take that 64 and I'm going to divide it by 12. And that is 5.3 repeating. That is the height of the woman, so that's going to go down here. Okay, the woman also is 40 inches, or the shadow is going to be 40 inches long. So what I'm going to do is I'm going to take that 40 inches and I'm going to divide it by 12. And that's going to give me 3.3 repeating feet. That's the length of my shadow. So that's going to come up here. And then we're going to cross multiply. When I multiply 50 times 5.3, repeating, I get 266.6 repeating. That's going to equal 3.3 repeating x. And then when I divide that, I'm going to get my value for my flagpole height to be 80 feet. Okay, so we're just going to divide that 266.666 divided by 3.33 repeating. The second piece of that asks, what if a child who's 58 inches tall is standing next to a woman? How long is the child's shadow? Okay, now we're not going to worry about the flagpole. We're going to convert everything into inches. Okay, I already know that my woman is 64 inches tall. Okay, she casts a shadow that's 40 inches long. So I'm going to take the shadow of the woman over top of the woman's height in inches. I know the child's height in inches, and I'm going to find the length of the child's shadow in inches as well. Okay, so this time I'm going to take 40 times 58, which is 2,320. And that's going to equal 64x. Now I'm going to take that 2,320, I'm going to divide it by 64. And that gives me 36.25 inches. And that is the length of the shadow for the child. Okay, at this point we're going to go ahead and let you get started on the homework for section 7.5.